Ledge Runner Part 3. So we'll continue from where we last stopped, but I decided we won't do the collision detection or the velocity or friction in this lesson, because I wanted to come like naturally, as if you coded this game, like from your level, from your perspective. So I'll figure out how to do it like a beginner as best as I can, because it's hard for me to think like a beginner because I'm a few years after that. So what we'll do in this lesson is we'll do the ledge behavior, the ledge spawning or movement. We'll see whatever we were able to do in 20 or half an hour. So a Y ledge will also have speed. It will be derived or will come from the global ledge speed. From this, when it's spawned, its speed will be equal to the global ledge speed, and the global ledge speed will change according to the points every 1,000 points using modulus. So we'll also want to check if it's active or not. If it's not active, like if it's off the screen, you stop making it active and remove its sprite. So if it's not active, you won't loop it, like you will continue when you loop all the ledges. You will ignore the ledge, because removing it, well, I found that removing game actors, game elements from an array can cause unexpected problems in my framework. So yeah, I'm extra careful here, so I'll use the Y-active attribute to simulate remove. Let's see. So we'll create a function called new ledge, new Y ledge. We'll create an object L as Y ledge and start populating it, and let's return it before we do anything. So ledge ID will be the current sprite counter. Where is it? Sprite counter. Sprite counter for the sprite's ID, whatever. If you have something other than a ledge, it's always good to have something that counts your sprite IDs and increments them. We'll increment it at the end. Actually, let's do it now. So before everything ends, you'll increment sprite counter because you just added a new sprite ledge. After that, we'll have the ledge speed. As I said, it will be equal to the global ledge speed. Here, first it will be 1, then 2, then 3. We won't make it bigger than 4, because then you won't be able to play the game for long. You won't be able to play the game for long anyway, because it's random and the ledges will get faster. But you can add stuff like power-ups to make it more balanced and skill-based and decision-based. Let's see. Y-active will be 1 at the start. So if Y-active is 0, don't update the ledge, don't move it, don't do anything, and remove its sprite. Let's see. The image ID will equal ledge speed plus 1, because ID 1 in the images is the player, so we'll use that will be the image ID for the sprite, the ledge sprite. Let's show you. 1 is the player IMG, so if the ledge speed is 1, it will be 2, and then 3, and then 4. So that way, the faster the ledges go, this image will change from I think I did it differently. This was 3 and the purple was 2. Like the first, if you remember the game, the ledges, they start as purple, and as they go faster they change to the grass and then to the lava. Okay, next. So let's see, let's do something to prevent any errors. In case the speed goes above 4 or above 3, and the image will be above 4, which we don't have an image ID with, no, above 4. So we'll have to make sure that the IMG stays 4, just to prevent any missing image error. Now we can create the sprite. .id and the IMG. That's it. And now we need to set its size. If you notice that the ledge size, its height is always the same, but its width changes. So let's do that. Set sprite size, not scale. Size, we'll change it to a specific pixel size. Let's first get the sprite's ID, the ledge sprite ID, so it knows which sprite to change, and then we'll do random (100 to 500). That's the width, and the height is the same. It's 40 pixels. Okay, so when a new ledge is created, it can be anything between 100 and 500 pixels. Okay. And finally, we'll insert the ledge we created to the ledge array. Ledge R, let's see if we actually, yeah, it's a ledge array. Great. So let's see what happens when we create a new ledge. Below the player. We create a test ledge, that will be the first ledge. TSTL equals new ledge. Let's run it. Yeah. And if I'll run it again, you'll see it will be in a different width. Yeah. Let's set its position a little bit below the player. Set sprite position. The sprite will be tst.id. Its x can be 0, its y will be 300. That's good. We'll start there. Let's run it again to see. Now it's wider. Great. So now let's see, what shall we do? We need do the move ledges. Let's see if it's in our game loop. Move ledges, yeah. Okay, great. Move them by Y. Oh, it's Y ledge. Okay, let's see, move ledges. So we need to loop all edges. That's easy because they're all inside the ledge array. So let's see. If ledge R at position of I dot Y active equals 0, meaning it's not active, then continue. Skip all the code we will write below it and go to the next ledge, the next iteration of the loop. Let's see. LID, it's the ledge ID. So if it is active, everything right now will happen. Ledge X equals get sprite X. See why I created ledge ID, LID? So we won't have to write all of this again and again and again. We'll need to do the same for the Y. Set sprite position ledge ID. Its X won't change, we only change the Y. Y minus ledge array at position I speed. Let's see what this will do. Now it moves up by the speed. Okay. So for now we'll just create, all the ledge features to do the easiest. So if ly, the ledge's y, is smaller than minus 100, it's off the screen 100 pixels, really outside the screen, make it inactive and remove it. So we make it inactive by making it equal 0 and delete sprite. LID, delete this current sprite. So now the next time the loop runs and it gets to this sprite, it will come here and move to the next sprite. That also so we won't have like 100 sprites moving outside of the screen and just wasting memory. So let's do the code that increments the ledge's speed. If modulus points, every 1000 times equals 0, and the ledge speed Where's ledge speed? Ledge speed is smaller than 4. We don't want the speed to go above 4. We don't want to make it too hard. Increment the ledge speed. And we'll have to decrease the spawn time duration. So you'll still have distance between ledges when they spawn. Like the time they spawn determines their distance between each other. Like if it spawns like every second or every tick, you'll have the ledges spawn very close. But if like it spawns every 10 seconds, you'll have one ledge spawn, go up a few pixels, and then another ledge spawn, and they'll have a distance between them. So that's what we'll do now. Decrease the spawn time duration by a second. And if okay. Oh, we don't have the points. The points. Oh no, I comment it out so we can see the player. Okay. Next. Let's do the spawn ledges. We won't handle heat detection or anything, we just want to do all the functionality for the ledges. So, if spawn timer done is smaller than the timer, you know, the seconds that have passed since the game started. If the timer done is smaller than the timer, meaning let's say the timer done is I don't know, 5 and the timer is 6, it means that the timer you know, is done. And then we'll reset the timer because we want it to happen again and again and again. So the way we reset the timer is spawn timer done equals spawn duration plus the seconds, yeah, plus get seconds. We did it in the last game tutorial, I explained it there a couple of times. I still prefer the way I do it with my own framework. Let's see. New Y ledge. I have the feeling we forgot something in new Y ledge. Set spite. Oh, I didn't do X and Y. In this case it will be full numbers, no need for floats. And set sprite position here. Set sprite because we need it so we can accurately position the sprites anywhere using this function and its argument. Forgot the comma. So l.id x and y, and that's not l. So now we can fix the test sprite. Get rid of this line. as in, we already have this line inside the new while edge. So all we need to do is do this. Will not change anything. I'll run it in a moment. You'll see all the changes. I first want to finish spawn ledges. New ledge. It will be... Where will it start? On the X it will be a random position between 0 to 400. So a ledge can spawn anywhere from 0 axis to 400 pixels. Okay, what else? I think that's it. Oh, the Y, forgot the Y. Get screen bounce bottom plus 20. We want the ledge to spawn off the screen from the bottom. 20 pixels to be exact. Let's see how this works. What's the problem? Variable get screen bounce. Oh, forgot the parentheses. It's a function. Okay, that's a big ledge. So now we'll wait for it to spawn the new ledge. Oh, here it is. Spawn the ledge. And when it gets to 1000, it will spawn. It's supposed to spawn a green ledge. So now we're done with one of the core mechanics of our game. All we have left to do is the collision detection and the physics part. The player, basically. Let's wait for it. There we go. Now it spawns green ledges. Yeah. I made it like that so you won't be able to stay on the green ledge for long when the transition happens, or else your character will be crashed and pulled up and you lose the game when you go off screen or to the top or to the bottom. Yeah, that was the goal of this lesson, to create this functionality of creating the ledges. Let's see, now, oh, it even spawns the new ones. The lava ones. Great. Perfect. So, if you don't understand anything, please contact me any way you can. For YouTube, for the AGK forum, for my contact form. And that's it for this lesson.